Okay, so if you are having any problem when I am going through this, let me know because there may be some network issues with me. So okay, so in the previous class we had discussed about the EEG, right? And today we are going to learn about the ECG. So the name ECG stands for electrocardiogram. Okay, electrocardio. The cardio itself represents that we are studying about the heart and then the gram. Okay, so what we are going to do in the ECG. Okay, so on in the ECG we are going to measure the electrical activity. Okay, like in the EEG, we had measured the electrical activity in our brain, the electrical activity produced by the neurons present in our brain. Similarly, in the ECG, we are going to record the electrical activity associated with the function of the heart. Okay, so whenever your heart is going to function, so what happens? There may be some electrical activity in your heart. Okay, I will explain you why, from where the electrical activity is getting generated. So what about the ECG is in the ECG we are going to record these electrical activities. Okay, so just remember EEG we are recording the electrical activity from the brain, and in ECG we are recording the electrical activity from heart. Okay, and then I will explain you from where the electrical activity has been, from where the electric impulses has been generated in the heart. I will explain you. Okay, so just remember, if you are recording the electrical potentials, okay, if you are recording the electric potentials that are available with the heart during the functioning of the heart, okay, then that particular recording of electrical activity is known as ECG. Okay, so now so what happens with the ECG is the 1 minute. Okay, what happens with the ECG is the waveform that we are recording have is being standardized in terms of amplitude and in terms of phase relations. Okay, so the waveform has been standardized in terms of amplitude and in terms of phase relations. Okay, if there is any deviation either in the amplitude, okay, if there is any deviation in either in the amplitude or either in the phase relationship, then it represents that there is some abnormality in your heart. Okay, so the wave of the ECG is standardized. Okay, so for all the human being, like not like that, like I said that in the EEG the peaks like this you are getting some wave, and this may be different depending upon the thinking process of the human being, right? I think in the EEG I had explained you that we can't go through the pattern. Okay, the pattern that my EEGs have one particular pattern and your EEG is one particular pattern. We can't go through the pattern. There we have to go through the frequency levels. Okay, like alpha, beta, gamma, delta, and theta. Depending upon these frequency bands in the EEG, we are um, considering whether the person is normal or having some abnormality, right? But in the ECG, whether when we are talking about the ECG, so what happens when you are talking about the ECG is in the ECG the wave is standardized. Okay, either it may be you or me or any other, the wave is standardized in terms of magnitude and in terms of phase relationship. Okay, if there is any deviation, okay, if there is any slight deviation in the ECG wave, then we can say that there is some abnormality and he must be treated for that. Okay, so I will explain you of the wave also. Okay, so what the important thing that you need to understand here is the electrical activity and associated mechanical sequence performed by the heart in providing the driving force for circulating blood. Okay, so the electrical activity, because why we are recording the electrical activity and what is the need for recording this electrical activity is depending upon your electrical activity. Okay, depending upon the electrical activity produced by your heart muscles are going to contract. Okay, that means when depending upon the heart muscles, the atrial and ventricles are going to contract and expand. Depending upon that, the blood circulation is going to happen. Okay, so I will explain you in a sequence. Okay, okay, so let me see show you. Okay, like this 1 minute, let me show you the heart. Okay, so this is your heart. Okay, you can see on the screen. I think you are now able to see on the screen. So this is your heart. So what happens is I am recording the electrical activity on this heart. Okay, so what is the significance of measuring this electrical activity? Okay, depending upon these electrical activities, the muscles which we call as an cardiac muscles, okay, let me explain you that the whole muscles in the body. The body is going to have different types of muscles. The whole muscles in our body can be classified into three different types. Okay, if you are classifying the muscles, the body muscles of a human body. If you are having a muscles of a human body, then you can classify all the muscles of a human body into three different types. Okay, so the first one is uh, skeletal muscles. Okay, I think that is right. Skeletal. The first one is skeletal muscles. Second one is cardiac muscles. Okay, and third one is smooth muscles. Okay, so the muscles of the whole body. Your whole body is having some muscles. The muscles of the whole body can be classified into three different groups. Okay, the first one is skeletal. Second one is cardiac, and the third one is smooth muscles. I think you had also learned about these muscles in our biomechanics subject also. Okay, so the skeletal muscles are those muscles which are present along with your bones, and which are the major muscles which cause a human being to move freely. Okay, so the skeletal muscles are important for movement. Okay, if you are moving, like your limbs are getting moved like hands and legs, then the skeletal muscles goes for the major role there. Okay, so the skeletal muscles are for movement. Okay, okay, and coming on to the second group, this is our cardiac muscles. Okay, the second group of muscles are known as cardiac muscles. These are the special muscles which are available only upon your heart. Okay, the muscles that are present upon the surface of the heart are called as cardiac muscles. Okay, which I am going to explain about you now. Okay, and then the other is the smooth muscles which are present in your stomach and all different parts. Okay, they are neither. Okay, so these are the three different groups of muscles that you are having in your body. So my interest, when I'm talking about the ECG, so I concentrate on cardiac muscles. Okay, so what is cardiac muscles? Okay, so the muscles that are present upon the surface of the heart. So this is your heart. So there are some muscles upon the heart. Okay, so what is the significance of these muscles on the heart? These muscles contrast. Whenever these muscles are going to contrast, all the muscles are going to do the same thing, contrast, right? So when these muscles going to contrast, these are going to contract our both the atriums and both the ventricles. Okay, and when as you know that when the heart atriums get closed, contracted, so this will push the blood into ventricle, and when the ventricles contract, so this will push the blood into lungs, and impure blood will be pushed to the lungs, and non-impure blood and pure blood will be pushed to different parts of your body through blood vessels, right? That means now come back in a serially backward. Okay, the blood is pumped by the heart. Okay, the blood will go to the blood vessels. How the blood is going to the blood vessels? When these particular ventricles are going to contrast, right? And now how these ventricles are getting contrast? These ventricles are getting contrast when the muscles upon the ventricles, you can see here the Purkinje fibers. Okay, when these muscles get contract. Okay, when these cardiac muscles get contract, then ventricle is contracting, right? So now how these cardiac muscles are getting contract? These are going to get electrical because of the electrical activity that is happening in the heart. Okay, that means if you consider, okay, that means 1 minute, this first electrical activity. Okay, and then because of this electrical activity, muscle contraction happen, and because of this muscle contraction, ventricle will contract, and because of the ventricle contraction, the blood will go into your blood vessels, right? So finally you can clearly say here that because of this electrical activity, the blood in your blood vessels are going, right? The bloods are flowing through your blood vessels. That means if there is any deviation in this electrical activity, then it indirectly present that the blood flowing through your blood vessel is also having some change in their flow. Okay, that which may in future may cause cardiac arrest or many other puncturing of your blood vessels or many other things. Okay, so that's the reason why measuring the electrical activity of the heart, okay, is important parameter which directly controls the flow of the blood in your blood vessels. Okay, so yeah, this is the chain. Electrical activity will cause contraction of muscles. Because of contraction of muscles, ventricle will contract. Because of contraction of ventricles, the blood will flow through the blood vessels. Okay. So that's the reason why it is important to record the electrical activity of the heart, and which is called here as an ECG. Okay. So have you understood this? समझ में आया आता?
सर
हाँ,
सर वो जो डायग्राम में जो पॉइंट्स पॉइंट समथिंग समथिंग कुछ लिख रखा था, डिजिट्स लिख रखे थे।
वो मैं बताऊंगा, वो मैं आपको बताऊंगा, उसका टेंशन मत लीजिए, मैं आपको बताऊंगा, ठीक है?
ओके।
उसका आप टेंशन मत लीजिए, मैं वो सारे पॉइंट्स आपको एक्सप्लेन करूंगा। मैं सिर्फ आपको जस्ट एक्सप्लेन करने के लिए मुझे डायग्राम आया था, डायग्राम मैं आपको एक्सप्लेन करूंगा, ठीक है?
ठीक है, ओके, फाइन सर।
ओके, सो now let us move to the other part. Now I have said that imaging the electrical activity is very important for us, right? But but how this electrical activity is getting generated at the heart? Okay, so the main reason, the main person who is behind this electrical activity is this SA node, okay, which is called as an sinoatrial node. Okay, because of this SA node, okay, because of this SA node, the electrical activity is going to happen. Okay, and never think that this SA node is an voluntary node. No, it is an involuntary. Okay, there may be some parts in your body which are called as an involuntary organs. That means you cannot control those organs by your brain. Okay, if you think that my SA node stop producing the electrical impulses, then it is not going to be controlled by the heart. Okay, they are going to be connected to some other part of the brain, I think some cerebrum, like that, cerebellum, and those are not controlled by you. They will be involuntary. That means they will be working automatically. They will not listen to your heart or your brain. Okay, like if you want to move a hand, it depends upon you. If the brain will give the instruction, and then your hand will move upward, that means the muscle in the hand is going to be controlled by your brain, right? But this SA node here is not going to be controlled by your brain. It will do it, but in a continuously way, it is not going to be controlled by the brain. Okay, though it is connected to the brain, but it is not going to be controlled by the brain. Okay, like the other muscles in your body, which can be controlled by your brain. Like if you think my hand has to move, then the brain will give the signal to the muscles in your hand, and your hand will start moving. But this SNOD is not going to be like that. It will work continuously. Okay, so now let us see what is this SA node. Okay, if in when we are going to the end of the syllabus, at that time I will explain you the pacemaker. Okay, so it is an artificial pacemaker when I am going to explain you at the last. But the natural pacemaker in your body is your SA node. Okay, you can see SA node here. So this SA node is a natural pacemaker for you. Okay, so this is going to generate the electrical impulses. That means it is an accumulation of a cells. There will be some cells. All these cells together start generating the electrical impulses. Okay, how many electrical impulses it is going to generate? I have written here. Okay, now if you are going to learn about the SA node, so the length of the SA node is between 25 to 30 mm, and the thickness of the SA node is 2 to 5 mm. Okay, this SA node here, this SA node is having a length of 25 to 30 mm and a thickness of 2 to 3 mm. Okay, and it generates impulse at a normal rate of 72 beats per minute at rest. Okay, where is my cursor? Okay. Okay, so that is the reason why your heartbeat is 72 beats per minute. Okay. This SA node will generate 72 impulses per minute. When it generates 72 impulses, because of this generated impulses, the heart will go contract and expand. The ventricles contract and expand, the valves close and open. So because of this SA node, everything is happening, right? So this is SA node. The size and length has been, the length and thickness has been given here, and this SA node is generating the electrical impulses, and those electrical impulses are how many electrical impulses it is generating? It is generating 72 pulses per minute. That is the reason why your heartbeat is 72 beats per minute. Okay. Um, so this is about the SA node. And if you consider the location of the SA node, So your SA node will be located top right near the entry of vena cava. Okay, so you can see here the SA node is present, and you can see here this is my superior vena cava, and there will be some inferior vena cava coming from here. Okay, so it is exactly positioned at the top right side and exactly at the place where superior vena cava gets opened. Okay, so it is present at the superior vena cava, near to the superior vena cava. This is the location for this. Okay, so what this is going to do, first it is going to generate the impulses, and these impulses will travel to both the atrium. Okay, when these impulses goes to both the atrium, then this atrium muscles are going to contract, and when this atrium contracts, the complete blood will flow into the ventricle, and when the blood reaches the ventricle, the electrical impulses from SA node travel via this and reaches here, which is called as an AV node, and from the AV node it will distribute from the Purkinje fibers, and then because here the muscles will contract and then the blood will flow outside. Okay, so this is how everything will happen. So now I have to explain you the time periods, right? So what, let me erase everything here. Okay, so initially 0.0, that means initially SNO generates the impulse. Okay, once the SNO generates the impulse, okay, uh, once the SNO generates the impulse, this impulse takes 0.025 seconds to reach the left atrium muscles, and it takes 0.06 seconds to reach the right atrium, okay, right atrium muscles. Okay, and then when after 0.025 seconds, 0.06 seconds, these two muscles get contrast, and then the blood will move to here. Okay, and after that this impulse will take 0.03 to 0. After 0.03 seconds this impulse reach here, and then this impulse will reach here after 0.045 seconds. Okay, that means after reaching AV node it takes 0.045 seconds. After that, from the AV node it will get distributed in the left atrium and right ventricle and left ventricle. So these are the different time periods: 0.015 seconds, 0.15 seconds, 0.9 seconds, 0.16 seconds, 0.2 seconds, like that. So these are all the time periods, how much time this electrical impulse take to travel to right atrium, left ventricle, right ventricle, and then to AV node, and then from AV node to all these things. Okay, so the numbers that I had represent here are the time periods that are taken by these electrical impulse to travel from the SA node to um, different points of your heart, because this electrical impulse from SA node has to travel to right atrium, then only your right atrium muscle is going to contract, and then this electrical impulse has to travel to left atrium, then only your left atrium is going to contract, and then it has to travel the AV node, and from the AV node it has to reach bundle of His. This is called as the bundle of His, and from the bundle of His it has to get distributed into small fibers which are called as then Purkinje fibers, and from the Purkinje fibers it will travel to the muscles, and these muscles will contract, and then the right atrium, right ventricle and left ventricle will contract, and the blood will be pushed out. Okay, so all the numbers that I have given here are the time periods here. Okay, so let me explain you again. Okay, what happens completely in the heart. Okay, so 1 minute. Okay, so first the electrical impulses are produced by this SA node. Okay, and once this SA node produces the electrical impulse, okay, the length and thickness has been given in the about text, you can see from there, and number of impulses produced will be 72 per minute. Okay, and from here the electrical impulse will first distribute in the right atrium and left atrium. RA will be right atrium and LA will be left atrium, and then this electric impulse will take 0.045 seconds to reach this AV node, and then after that AV node it will travel again to reach this bundle of His. Okay, this is called as a bundle of His, and from the bundle of His this electrical impulse will get distributed in the right and left through Purkinje fibers, okay, which is called a Purkinje network. So you can see the small branches here, which are called as a Purkinje networks, and these are the end points. And from this Purkinje network, these electrical impulse will go to the muscles, and when the electrical impulse reaches the muscle will contract, and then the right atrium and left right ventricle, you can see RV here, right ventricle and left ventricle will contract, and then it will pump the blood. If it is left ventricle, it will pump the blood to the blood vessels, and right ventricle will pump the blood to your lungs for purification. Okay, so this is all what happens in the blood. Okay, this is how the electrical impulse will travel via your heart. Okay, so all the numberings are the time period taken by that electrical impulse to travel to different parts of your heart. So have you understood this?
Yes, sir.
तो आपको वो टाइम पीरियड्स जो पूछे थे आपको समझ में आया वो टाइम पीरियड्स क्यों दिया है?
जी सर, आगे समझिए।
Okay, okay. So next, now let us move to okay. I think now we are familiar with the electrical impulse from where these electrical impulses are getting generated. So now let us move to the next part of the ECG, that is the waveform. Okay, you have learned the time period that is taken by the electrical impulse to travel via heart. That means you are now familiar that the impulse will be generated as SA node, synatrial node, and then it will reach the AV node. AV means atrioventricular node. This is some name I didn't remember now, but if you Google it, then you can get the name. So from SA node, it will travel to AV, and then from the AV to the bundle of His, and from the bundle of His to the Purkinje fibers, and from the Purkinje fibers to the ventricle muscles, and then from the ventricle muscles will contract. Okay, arterial muscles will directly get the these atrium muscles. Okay, these are atrium muscles will directly get the impulse from SA node because it is near to the atrium. So left right atrium immediately gets the impulse, and left atrium will take some time, and the left atrium will get the impulse. But for the ventricles, this impulse has to travel from SA node to AV node, and then bundle of His, and then via Purkinje fiber, then only it will reach the muscle state. Okay, it takes some time for reaching the ventricle, but it will immediately travel first to the right atrium, and then sometime after right atrium, and then it takes some time to reach your ventricles. Okay, because the ventricles having some length there. So now this is the normal wave pattern of an ECG waveform recorded in a standard lead position. Okay, there will be some lead positions. You may come across that when we are going further in this topic. So this is the standard wave. Okay, so the standard wave of the ECG. Okay, this you can see on the screen. So this is the standard wave of the ECG. So these have been labeled. Okay, this ECG has been labeled like P Q R S T U V. Okay, the V is not that much significant, but you have to know about what is the P wave, what is this QRS. This is the QRS wave, and then what is the T wave. So what they represent. Okay, what the P wave represent, what the QRS complex. Remember that this Q, R, and S. Where is this mouse? Okay. So this Q, R, and S. This is called as an QRS complex. Okay. So this QRS, what is this QRS complex? And then this T wave, this U wave. So they having some time periods, and they are going to represent something. Okay. The P wave is representing something. The QRS complex is going to represent something. The T wave is going to represent something. So they are going to represent something. Okay. So what are they going to represent there? I will explain you. Okay. So this is just standard ECG wave, or you can call it a typical ECG wave. Okay. Um. So the waveform is divided into P wave, Q wave, QRS complex, and then T wave and U wave. Okay. So 1 minute. Just wait for 1 minute. Huh? So let us see this QRS wave. Okay, so now what we have to see here is, let me explain the text that I have written here, because have I shared you the transducers and the EEG PPT? Have I shared you the PPTs or not? I think I have not shared the both the PPTs, the transducer one and the EEG one.
नो सर, दोनों ही नहीं आई है.
ठीक है, मैं आपको शेयर कर दूंगा. Okay, so what I had written in the text is, um, starting from the P up to R or up to PQ, that particular time interval is the time interval taken by the SA node to reach the ventricles. Okay, that means starting from this P wave, okay, starting from this P wave up to Q wave or up to R, you can consider R or Q, both are very close to each other. So let us consider the Q, okay. So starting from this P wave to up to Q wave or R wave, because the Q and this is the Q and this is the R. This wave is known, this spike is known as R, and this depression is known as Q, and this particular depression in the wave is known as S. So starting from this Q wave, you can see the Q P wave here. Starting from the P up to Q or R, the time taken. Okay, this is a curve between the time period. Okay, the y-axis here will be the time period, and the sorry, this x-axis will be the time period, and this y-axis will be the amplitude. Okay, this is a curve plotted between the time period and the amplitude, but I have not represent that. Okay, but the time taken from this P wave up to Q or R, this particular time interval, okay, this particular time interval, you may call it a, this is the time taken by the impulse which has been generated at the SA node to reach the AV node. Okay, so this particular time period is known as the time taken by the impulse um, to reach the ventricles. Okay, and then the PR interval. Okay, okay, this P2R. Okay, is the time taken by the impulse to start from the SA node and reach up to the ventricle, and that particular time period will be 0.12 to 0.2 seconds. Okay, okay, so I think now you are clear that starting from P up to R, okay, starting from P wave up to R, the complete time period, okay, this particular complete time period is the time taken by the impulse which has been generated as a node. It is the time taken by the impulse to travel from the SA node to the ventricles. That means up to the AV node, the time taken by them is called as an PR, from PR interval, and the time period lies between 0.12 to 0.2 seconds. Okay, and then now come on to the QRS interval. Okay, what is this QRS interval? Okay, so this particular QRS wave, or you can call it as in QRS complex. Okay, here is my mouse. Okay, so this particular QRS complex starting from Q and then R and then S. Okay, this particular QRS complex is the time taken by the impulse, because before the QRS complex, the wave, the electrical impulse has been traveled from SA node and reaches up to the ventricle part. So what is this QRS is? This is the time taken by the impulse to travel via the interverticular system. That means via the Purkinje fibers and reach up to the muscles of the ventricles. Okay, it is the time taken by the impulse to travel via the intraventricular system. That means travel via the his bundle of his, and then to the Purkinje fibers to the walls of the ventricle. Okay, that particular time is taken by, is represented here with QRS complex. Okay, this QRS complex is representing that itself. Okay, so what will be the time? So that will be 0.05 to 0.1 seconds. Don't consider like that this is 0.12 and this is, I am just talking about this QRS wave. This QRS wave is taking, that means first the, let me, first from the SA node up to the AV node, it has taken 0.12 to 0.25 seconds. Apart from this, and now from AV node, if you consider from AV node up to the walls of the two ventricles, the time taken by them is 0.05 to 0.1 second. Okay, so this okay, so this time is from AV node to the walls of the ventricles. Okay, this time is from SA node to AV node. Okay, that means the PQ interval is representing the time taken by the impulse from SA node to the AV node, and this QR is representing the time taken by the impulse to travel. That means this is a time taken by the impulse to travel from the AV node to the intraventricular system. Okay, and then the T wave, which is the last wave. Okay, this T wave represents the repolarization, because this QRS, once after the QRS wave, as the impulse has reached the walls of the ventricle, so after that the ventricle muscles get depolarized and they are going to get contact. Okay, and then again this T wave represents the complete repolarization. That means again they start repolarizing. Okay, and if you consider the QT wave, so this is the time period. This QT wave can be called as a complete ventricular contraction. Okay, so because uh, let me summarize. It may be confusing for you. Okay, okay. So now let me do one thing. Okay, let me do one thing so that you can easily understood. Divide this wave in the form of articular section and ventricular section. Okay, articular section and ventricular section, like the different divide this. That means upper part of your head and lower part of your head. Okay, so let me erase everything. Okay, so starting from the P up to the Q. Okay, this PQ interval, you can call it as an articular section. Okay, and starting from the Q up to the T wave, you can call it as an ventricular section. Okay, now it may be clear for you. Starting from the Q up, starting from the P up to the Q, it will be your articular section, and starting from the Q up to the T, it will be your ventricular section. Okay, so now let us try to understand the things. Okay, so this is the P wave and this is the Q wave, and this complete is known as QRS complex. So the time taken, the time period, if you measure the time period of this wave starting from the P up to the Q, that means if you are measuring this PQ interval, I have called this an articular section. Okay, what this means that during this PQ interval, the wave will get generated SA node, will travel from the SA node to up to the ventricular, that means up to the AV nodes. Okay, or you can call it as a bundle of V's. Okay, that means it is traveling via articular section and then reaching the ventricular part. Okay, and the time taken for that will be 0.12 seconds to 0.2 seconds. Okay, and then once the impulse reaches the ventricular part, what happens? This impulse will travel via the Purkinje fibers and will distribute across the ventricular walls, right? So this particular QRS complex, which you can see here. So this particular QRS complex is that particular QRS complex. This, but this is the time period taken by the impulse to travel via the Purkinje fibers and reach the ventricle muscles. Okay, what happens after reaching the ventricle muscles? So ventricles are going to contract and then it is going to pump the blood out. Okay, so that is the reason why after that the repolarization will happen. Okay, that means that what happens during the QRS complex, the impulse will travel via the Purkinje fibers. Where the Purkinje fibers are present, they are present on the walls of the ventricles, right? That means they are traveling via this valves. That means they are in ventricular section, and after completing the QRS complex, these two ventriculars will contract, and then again the repolarization starts happen. That is the reason why I had classified this QT interval as ventricular section. Okay. So during the PQ, it will the impulse will travel will go automatically to the atrium, and then it will reach the AV node. And this during this QRS, this will travel via the complete Purkinje network and reach the walls. And during this T wave, it will contract the T wave, and then again it will relax, and again the P wave will start. Okay, so this section P2Q is called as articular section because the wave is traveling from SA to AV, and this QRS is the section where the wave travels across the ventricular, and then during this T wave it will contract the ventricle, and then again repolarization happen, and then again the Q wave will happen, right? So that means this PQ is only the section during this PQ the wave is at the ventricular part. After this, during this QRS, this is traveling by Purkinje fiber, that is the ventricle part, and then during the T wave, the ventricles are contracting, that this is the ventricular part. So that's the reason why I had classified the Q to T as the ventricular section, and then again this TP time period is the repolarization time period, and then again the P wave will start. That means starting from this P wave up to this P wave, this is called as an half cycle. That means P2Q is called as an articular section, Q2T is called as a ventricular section, and P2P is called as a complete half cycle. Okay, so have you understood this? समझ में आया नहीं है?
सर
Yes, sir.
क्या हुआ? समझ में आया? कोई डाउट है?
नहीं सर, समझ में तो आ गया सर, बस वो यू वेव का कुछ यूटिलिटी समझ नहीं आ रहा है।
ओके, वो यू वेव का क्या है? वो यू वेव कुछ नहीं कर रहा है, वो सिर्फ दिस इज रिप्रेजेंटिंग दैट एक बार हार्ट आपका वेंट्रिकल कॉन्ट्रैक्ट हो गया है ना, उसका फिर से क्या होगा, आपका वेंट्रिकल और आर्टरियम दोनों अपने नॉर्मल पोजीशन में आ जाएंगे ना। सो वो यू वेव वही रिप्रेजेंट कर रहा है, मतलब रीपोलराइजेशन, मतलब फिर से वो अपना नॉर्मल पोजीशन में आ जाए। दैट मींस अगेन फिलिंग ऑफ ब्लड will happen in the atrium, right? So that is represented by the ventricles.
अच्छा, तो सर बट टी वेव भी तो रिपोलराइजेशन ही शो कर रहा है।
तो वो गलती से वो नॉर्मली वो मैं यहाँ गलती से टेक्स्ट लिखा होगा, एक्चुअली कुछ यहाँ रिपोलराइजेशन है। एक्चुअली टी वेव के समय क्या हो रहा है कि डूइंग द टी वेव द वेंट्रिकल्स आर गेटिंग कॉन्ट्रैक्टेड। ओके, टी वेव के समय वेंट्रिकल्स गेटिंग
सर आपकी
कॉन्ट्रैक्टेड।
आवाज डिस्टरप्ट हो रही है बार बार।
एक मिनट।
हेलो,
अब आ रहा है आवाज सही से?
हेलो,
अब आवाज आ रहा है आपको?
सर शायद यहाँ पे नेटवर्क इशू आ रहा है थोड़ा।
अच्छा, मैं करती हूँ, इससे नेटवर्क इश्यू आ रहा है यहाँ, ना तो जियो चल रहा है ना तो एयरटेल सही से चल रहा है। सो अब आ रहा है आवाज क्लियर? थोड़ा तो आ रहा है क्लियर?
हाँ सर ठीक है, इट्स फाइन।
ओके, सो वो टी वेव के समय क्या होता है कि वेंट्रिकल विल गेट कॉन्ट्रैक्टेड ड्यूरिंग द टी वेव। ओके, सो यू वेव जो होता है वो रिलैक्सेशन टाइम बोलते हैं। हार्ट का जो रिलैक्सेशन टाइम होता है वो आपका यू वेव होता है। एक मिनट आपको,
ओके,
मतलब यहाँ क्लियरली देखिए यहाँ क्या लिखा हूँ कि वन कंप्लीट वेंट्रिकुलर कॉन्ट्रैक्शन विल हैपन एट द टी वेव। ओके, एंड स्टार्टिंग उसके बाद क्या होगा, आपका वेंट्रिकल डायस्टोल विल स्टार्ट from the end of the T wave. That means from the end of the T wave, the U wave will represent the diastolic phase. What is the systolic and diastolic phase? During the systolic phase, your contraction will happen, and during the diastolic phase, again refilling of blood will happen. Okay, so वहाँ पे repolarization मतलब यहाँ ये है कि
ओके,
during this
ओके सर।
T wave, ventricular contraction will happen. सुनाई दे रहा है? फिर से आवाज कट रहा है।
सर थोड़ा डिस्ट्रप्शन तो हो रहा है बट ठीक है सर, समझ में आ गया। वो डायस्टोल की वजह से, वो रीफिलिंग की वजह से यू वेव आता है, तो वो मैं ठीक है,
हाँ
चमक
हाँ
गए।
हाँ, ठीक है। तो
ओके, थैंक्स सर।
आज के लिए इतना पढ़िए, ठीक है, क्योंकि सब एक ही दिन बनाऊंगा, फिर से आप कंफ्यूज होने लगेंगे। This will take up to three classes because I will explain you small parts. Okay. So today इतना ही था कि what is the first thing? The ECG is nothing but a recording of electrical activity. हाथ में जो electrical activity है, we are recording that particular thing. Okay. And then it will be we are going to consider the abnormality depending upon the amplitude and the phase relationship here. Okay. And then what we can say that what it has explained you what is the significance of this, because depending upon the electrical activity your muscle will contract. Depending upon your muscle contraction, कोई और माइक ऑन में रखे है क्या? Okay. So what happens, depending upon your electrical activity your muscle will contract, and depending upon your muscle contraction your blood will ventricle is going to contract and then the blood will flow. So if you want to know the condition of your heart, then it is definitely needed that you should record the electrical activity in your heart. Okay. And then I'll explain you about the SA node, and this is the diagram which represents the time period that is taken by the impulse to travel via all the parts of your heart. Okay, and then I have explained you this particular standard ECG waveform. Okay, तो यहाँ तक कुछ डाउट है?